All right, let's jump into this. We're looking at something pretty concrete today: waste. Specifically, all the packaging that comes from processing agricultural stuff, think crops turned into food products. How do you actually measure that waste reliably? It's tricky.
It really is,
Yeah.
especially because it's not always consistent, right? The
Mm,
amount can change quite a bit.
exactly. And our source material takes us somewhere maybe a bit unexpected for the answer: mathematical integration.
Hmm.
Yeah, like calculus integration. The source gets into the specific link between that abstract math idea and the very real world problem of estimating packaging waste.
That's the core idea.
Hmm.
It's about seeing integration not just for, finding the area under a curve or in physics calculations, but as a practical tool. The source suggests using it to estimate the total amount of packaging waste when you're, say, processing raw agricultural goods into finished items. A practical application.
Okay, hold on. So using calculus dot integration to count like cardboard boxes and plastic wrap. How does that work? I mean, I mostly remember integration dealing with continuous things, areas, volumes. How does it apply to waste that might pile up over time or maybe differ from batch to batch?
Yeah, that's the clever part the source points to, conceptually at least. Think about integration as fundamentally a really powerful way to sum things up, especially things that are changing. So if you can figure out a function, some kind of mathematical description, for the rate that packaging waste is produced,
Yeah.
maybe compared to how much stuff you're processing, or perhaps just over time, then integration lets you calculate the total amount that's accumulated.
Ah, okay.
Instead of just grabbing a few bins at random to weigh or manually counting pieces, which can be messy and inaccurate, especially if the waste stream isn't steady, integration gives you a way to estimate it based on a model of the process itself. More rigorous.
So you're integrating the waste function, so
Yeah.
to speak.
Basically, yes. You integrate that waste generation function over the total amount of commodity processed, or maybe the total time the production line was running.
Right. Okay, that clicks. So it's less about guesswork and averages and more about modeling the rate like this much waste per ton of corn, maybe, and then integration sums it all up for the total tons processed.
Precisely. It moves you away from just simple counts or rough averages
Hmm.
to something that can actually handle that variability. It gives you a cumulative total based on how you understand the underlying process works.
Hmm.
Really useful for big operations where trying to track everything manually is just, well, not feasible or not very accurate.
And that's where it gets really interesting for the real world, isn't it?
Hmm.
Because if you can estimate waste more accurately using a tool like integration, well, that's not just a neat math trick. For businesses, that means better data. Maybe for managing resources better, cutting down on packaging, or even just reporting their environmental impact more accurately. It gives calculus a very practical job.
Yeah, with real implications for things like sustainability goals and even costs.
Definitely.
And stepping back, it just shows how these sometimes abstract-seeming mathematical tools can actually tackle complex physical problems out in the world. This kind of quantitative approach, using integration to model and estimate waste, pushes towards making decisions based more on data, better data for environmental impact, for operational efficiency.
Seeing the math hidden in everyday problems.
Sort of, yeah. Finding the utility in unexpected places.
Okay, so let's wrap this up. The main takeaway here from digging into the source is that integration, yeah, that calculus concept isn't just theory. It offers a potentially powerful method to get a better handle on something very tangible: estimating the packaging waste from processing agricultural products, a more robust way than just simple counting.
Exactly. And that leaves us something for you, the listener, to think about. If integration can help estimate waste in agriculture by modeling these rates and summing them up, how might really understanding and applying these kinds of quantitative tools, tools that can handle variability in accumulation, change how we tackle waste reduction? Not just in this industry, but maybe it sparks ideas for using similar mathematical thinking in completely different areas where you need to track how things add up over time.